Good morning. This is a 24-inch 90 series pressure reducing valve. Its main purpose is to look at the pressure downstream and to make sure that it meets the demand downstream, okay, according to what is set on the spring and the pilot here. The pilot here is the CRD is what we call this. This is the brain of the main valve. Without the brain here, the pilot, or any of the other components, this is just a very dumb basic valve. It doesn't do anything. So we put the controls on it to make it do what we want it to do. In this case, the pilot here is normally open. It's looking at the downstream pressure right through the discharge port, the same port that it discharges downstream. It needs at least 10 pounds across the valve to burn to have it operate correctly. Meaning that we're set at 45 pounds on the spring here. It needs at least 55 pounds. We like to see 55 pounds upstream at least to have it reduce that pressure effectively. Otherwise it gets a little bit slow. And we can do it with less, but it takes a little bit longer to do that. So normally when the valve is open, we have all three of these isolation ball valves here open, the downstream, the cover, and the upstream ball valve. All three of those are in the normally open position. When they're in the normally open position, this valve is ready to go. When we have the butterflies open, this one's upstream is open, this one is closed. The valve will automatically reduce pressure from upstream to downstream. So if we were to open our downstream butterfly, we would have continuous flow going through the valve because it's looking for that 45 pounds that we set on the spring here. Okay, you do that by putting a gauge somewhere downstream on this line here.
Did you set this one already?
I set this one already. I set basically it on the pilot here.
Right.
We weren't able to get 45 pounds downstream at the time.
Okay.
But basically I just set the pilot, and so the main valve will respond to that pilot setting.
Did you have that crank closed to build up that pressure upstream so you can then set it to 45?
Basically what I did is I closed our downstream ball valve, put a gauge on this extra downstream body port here on the pilot.
Right, okay.
Keep our upstream ball valve open. Well, with a little bit of leakage coming out of the pilot, we're basically just controlling the pressure in this outlet chamber right in the pilot.
Right, okay.
So it was basically reducing pressure. And once we open the ball valves up, it'll begin sensing pressure downstream.
Okay.
Start flowing from the Philadelphia line to the downstream manifold.
Right.
So once it reaches 45 psi on this side, it doesn't allow anything.
That's right. That's right. Once it gets up to the spring tension here, what happens is the hydraulic pressure overcomes the spring in here. Okay. Forces up a little diaphragm assembly. It closes off the pilot right here. At this point, water cannot any longer pass through the pilot. So our higher upstream pressure comes through here, can't go through the pilot anymore, comes back up to our cover connection line, pressurizes the cover chamber, starts slowly closing the main valve. And then once pressure downstream falls off again below the set point on the spring, the pilot will open up again, allowing more flow through here. And this is the magic of the valve when it opens. It does need a restrictor fitting like this one here. It has a red dye to mark that it is a restrictor fitting. It's not just a regular half union flare fitting. It does have an orifice, a Delrin orifice to it, probably I'm thinking about 1/8 inch orifice. Okay. What happens when the pilot opens? Water does flow through here, but when it gets through the restrictor, the pressure is now reduced. The pilot is taking more flow or more pressure off the cover than what is being supplied on to the cover here through the restrictor. When that happens, there's a drop in pressure in the cover chamber, beginning with 2 pounds on up to 15 pounds. When that happens, the higher upstream pressure will now push open the diaphragm assembly, because now we have a lower pressure in here than we do upstream coming in. Okay. And that's kind of the magic.
So if this does, go ahead.
The pilot will continually modulate. It's continually adjusting its position. When it adjusts its position, the main valve adjusts its position. So you can look at it as whatever position the pilot is in, the main valve is in that same position. If this is open, main valve is open. If this is closed, main valve is closed. But somewhere in between, that's where the main valve is going to be. If you're in a crunch, you need to close this valve off drip tight. Simply just close the downstream ball valve in the position that it's in right now. It's a lot faster, a little more effective than, you know, cranking on a hand wheel on a butterfly or a gate valve. So currently, if we were to open both butterfly valves, keep this closed, the main valve is going to be in the closed position. We're not letting cover pressure escape through the pilot system. We're basically simulating a closed pilot here. That's what we're doing. This valve does not care about upstream pressure, and it does not care about flow rate. It only cares about downstream pressure. Okay? That's the only thing it knows.
So I just had a question in case this needs to be adjusted.
Okay.
If you want to increase the pressure or decrease the pressure.
Okay. When you want to increase pressure, you go clockwise on the adjustment screw.
Okay.
You increase the spring tension in here, basically, is what you're doing. What you're saying is, I need more hydraulic pressure to overcome the spring now to get the pilot over. Okay. Thus, you're raising your set point downstream.
Right. Okay.
Is there a certain like PSI per turn, PSI increase per turn, or is it just by like say one full turn, how much PSI does that increase it by, or do you just eyeball it by looking at the pressure gauge?
You can extrapolate a set point.
Does this pop off?
Yeah.
Does it twist off? Okay.
This particular pilot here has a 30 to 300 range, which is indicated on the cap. With this particular spring, there's a 28 pounds per full turn. Okay, extrapolation to it. Let's see, this is our opening speed control here. It controls the opening speed only, okay? It does not control the closing speed. That is indirectly controlled by the orifice size and the fixed restrictor here. This is adjustable, the opening speed is adjustable. When we back out on the needle here, that opens up this orifice in here. So now that we can actually pull more water off the cover, get more flow going through the pilot out to the downstream side. So when you back this off, you're going to increase the opening speed of the valve. When you drive it down, you're limiting that orifice size, and so less water comes off the cover. So basically, you're metering the amount of water coming off the cover chamber to open the main valve.
Is there a area to put in a gauge to gauge the pressure?
Right here.
Right there? Okay.
These two ports here are common. There's two downstream ports. These two are common.
Okay.
You can put a gauge in here. If we don't have a bause or a place to put a gauge, we can plug one in here.
Okay. All right.
That'll give us our downstream pressure. Working our way back through here, just a simple Y strainer that filters out the debris so that it doesn't get caught in our, we call this an X58 restrictor.
Okay.
Periodically that does need to be cleaned out and checked about once a year. If we have a strainer that's full of debris, we can't get flow through here, what's going to happen is it's going to limit our valve's ability to close. Okay? It does take higher upstream water to get into the cover chamber to close it. So that does need to be checked periodically.
Any questions?
Any questions? They're good.
All right. Thank you very much. Appreciate you coming.
Thanks, Jeff.
We do have another